We present a deep generative model for landscape videos that can be trained on a combination of images and videos. In this slide, you can see synthetic samples created by the model trained for the resolution of 256 by 256. Our model has an augmented StyleGAN architecture. Compared to the original StyleGAN, it has a separate set of latent variables that models dynamic factors of variation. We have also added a special pairwise discriminator network, which takes unordered pairs of real images as real samples, and forces the main generator to animate dynamic objects via resampling spatial input. We have progressively trained our model to generate videos at resolution of 512 by 512. Here you see synthetic samples from the model, animated by applying homographa transformation to the added set of dynamic latent variables. Here, we show how ablations of our full model affect the quality of the samples. While our full model generates samples with plausible motion, samples from ablated versions contain many artifacts. Our method can be used to reenact static photographs. For that, we develop an inference pipeline, which takes the given photograph, and find the corresponding latent variables, as well as adjusted generator weights, such that the photograph is reproduced. We can then animate the given image by changing the dynamic latent variables. Here, we show reenactments of static images at 256 by 256 resolution. Note highly realistic cloud motion, as well as water movement in some videos. These reenactments were obtained at 512 by 512 resolution. We use a three-step inference procedure. In this ablation study, we show that all three steps are important in order to both match the input image and to animate it in a plausible way. In order to push our model to even higher resolution, we have designed a special super-resolution network that takes as an input the input static image, its semantic segmentation, and the results of our reenactment at lower resolution. In this way, the videos at resolution of up to 1024 by 1024 can be created. Here, we show the result of our system on out-of-domain examples, such as historic photographs and paintings. We compare our model with three recently introduced methods. The first one is two-stream, the second one is StyleGAN, and the last one is animating landscapes. Our system generates more plausible videos with stronger movements of objects in the scene. To train our model, we have used relatively small dataset of videos, mostly focused on cloud motion. It also had relatively few urban scenes. Consequently, our model often fails to reenact underrepresented types of landscapes well.